Here we have problem 7 from section 2.4. We're supposed to take a revenue function given by this equation here and then answer two questions about it. Well, examining that revenue function, first we see that it's quadratic because the highest power term in its rule is a 2. There's a quadratic term. There's a linear term where the exponent is a 1. And notice that you don't see a constant term. That's because there, c equals 0. Therefore, the y-intercept equals 0 for this function. Also further observe that a is less than 0. Therefore, the graph opens down. Before I dive into answering any questions about this, I'd like to take this much information and put it into a quick sketch of a graph. Well, the y-intercept is 0. That means the graph goes to the origin. That's also an x-intercept. The graph opens downward probably means the graph will look like this. It'll be an inverted parabola. I'm making the assumption that the other x-intercept is on the positive x-axis, because if it were on the negative x-axis, then our maximum price, the highest point, would occur when the price is negative. In other words, we're paying people to take our product away, which means that we have a pretty crummy product, and I simply prefer to assume that things are more optimistic than that. So I'm going to assume that my graph looks like this. Now, what price should be charged to maximize the revenue? Well, the maximum is that highest point there. It's also known as the vertex. So what price, in other words, what is the p that will do that? P is taking the place of x in this problem. We have a p-axis. Likewise, r is taking the place of y. And the second question is, what is the maximum revenue? What is the r at the top there? So, now there are two ways to go about this problem. I'm going to work it both ways. And I'm going to work it the first way as though we had never learned about vertices or the vertex formula for quadratic functions. I'm going to use the simple geometry here that this maximum value's location is halfway between the two x-intercepts. So if I find the two x-intercepts and find the point halfway in between them, then I've got p without having to do any special formulas. So first off, I'll need to have the x-intercepts. If I'm looking for x-intercepts, that means that r equals 0. Remember, r is taking the place of y. So 0 equals negative 3/7 p squared plus 4900p. Without a constant term, I don't even have to bother with the quadratic equation. I can simply solve this with a very easy factoring. There's a p common to both terms. And in fact, there's a negative common to both. And I'm going to pull out a negative p. That will leave us a positive 3/7 p in the first term. Pulling out a negative from the positive will leave a negative. And I could check that if I wanted by distributing the negative p back through and getting back to the previous step. Since this expression is a multiplication and it equals 0, I can use the multiplication property of 0. The first factor will equal 0, or the second factor will equal 0. Well, we already knew that p equaled 0 was one x-intercept, so there's no revelation there. We'll find the second x-intercept by solving the second linear equation. 4900 equals 3/7 p, adding a 4900 to both sides. And then Multiply both sides of the equation by the reciprocal of 3/7, which is 7/3, 4900 times 7 divided by 3. We get 1, 1, 4, 3, 3, and 3 remaining is P. I'm going to put a $ unit on that just to remind myself that I do have to think about units occasionally. Well, that gets the second x-intercept, 1, 1, 4, 3, 3, and change. We want to know what this x-intercept is. So the max is at a P which equals the average of the x-intercepts. Well, the way you do the average of two numbers is you add them together and divide by 2. So 0 plus 1, 1, 4, 3, 3.3 repeating, divided by 2. That means I can simply take the number that I've got in the display of my calculator and divide it by 2. 5, 7, 1, 6, with 6's repeating forever. So that answers the first question. Now, we need to answer the rest of the question. In other words, what is the second question? And I think that if I take a little bit of paper down here and continue, I can do that. So, in other words, for the second question, I need to know what is this R. Well, the way you get the R is to use the function. So, the max revenue will be R of 5, 7, 1, 6. 6 is repeating. So it will equal -3/7. 5, 7, 1, 6. 6 is repeating, all squared, plus 4900 times 5, 7, 1, 6. 6 is repeating. I'm being so cavalier about these numbers because I'm not actually going to do the work myself. I'm going to let the TI-83 do it. And I already have the input value for P in the display. That means I don't have to type it again. I can do -3 divided by 7 times second answer squared plus 4900 times second answer, and get a fairly largish number, 1400 5833 with 3's repeating. So revenue will be something on that order. And I think, to be honest here, I now need to think about what my significant digits should be. We're in the 14 millions. I think I would be able to tell my boss 14 million to the nearest thousand, 6,000, without blushing. Okay, now there's another way to work that problem, and it involves using the vertex formula to find the value of P that we found here. So I'm going to back up to the very beginning, and I'm going to pretend that I haven't done it the first way. So we have max revenue at P equals the x-coordinate of the vertex. So we know that in this case P would be -b divided by 2a. We're using the first part of the vertex formula. Well, B is the 4900. A is the negative 3/7. So this is going to be negative 4900 divided by negative 3/7. If I rewrite that a little bit, a negative divided by a negative is a positive. I will get 4900 times, I need to have a 2 in there too. So it's still positive. I've got a 6 over a 7, so that would be the same thing as dividing by a 6 and multiplying by a 7. On my calculator, 4900 times 7 divided by 6. And I get the exact same number here that I had for P on the previous page. So P equals 5716. 6 is repeating. Then you do R of P equals R of 5716. 6 is repeating as in the last page. So there are two ways to solve that problem. I would expect that you would be comfortable solving it either way. You want to understand both ways, because that means that you're making the conceptual connections that you need to keep all of this material organized, and you're just not simply memorizing a bunch of unconnected facts that will get all tangled up when you try to take a test.